defining a geometric sequence. In Core 1 we looked at arithmetic sequences and we found a rule for finding the nth term of an arithmetic sequence. Well, in Core 2 we're going to look at finding the rule for the nth term of a geometric sequence. And remember, a geometric sequence is where we multiply by a common ratio to get from one term to the next term. Now, the two bits of information we need to find the nth term rule for a geometric sequence is we need to know firstly the first value a, and we need to know the common ratio r, which is what you times by to get from one number to the next number in the sequence. So in this little table here you can see that a is represented as the first term. The second term is represented by doing a times the common ratio. Then to get the third term, you multiply by the common ratio again, which is why it's r squared. And to get the fourth term, you multiply by r again to get a times r cubed. So that means that the nth term rule for a geometric sequence is a times r to the power of n minus 1. The reason it's to the power of n minus 1 is if you look at the second term, you've got r to the power of 1. The third term is r squared, and the fourth term is r cubed. So it's always one less than the term we're looking at. Now we're going to use this to find the 10th and the nth term rule for the sequence 3, 9, 27 and 81. So we have an example of how these are labelled. We're just going to write each of these in the form shown in the table. So the first term is a is equal to 3. The second term is ar equals 9. The third term is a times r squared equals 27. And the fourth term is a times r cubed equals 81. Now what we need to identify is the first term, which is obviously 3. And the common difference is what do we times 3 by to get to 9, which is 3. Now we can use this to try and find the 10th term and the nth term for the following. So if we're trying to find the 10th term, we need to substitute 10 into our equation for finding the nth term. So a r to the power of 10 minus 1. Well, our a is 3 and our r is 3 and 10 minus 1 is 9. If you do this on a calculator you get the answer 59,049. Now the nth term rule, yet again using this fact here, we're going to have a r n to the minus 1. Well, our a is 3 and our r is 3 and our n to the minus 1. So that is the nth term rule for the following. Now let's try and apply this to a more exam style question where we're told the second term of a positive geometric sequence is 4 and the fourth term is 8. Find the exact values of a the common ratio, b the first term and c the 10th term. So the second term, ar is equal to 4, and the fourth term, a times r cubed, is equal to 8. Now, can we link these two equations? Well, yeah, they've both got the value of r. What would be to happen if we were to do, let's say, this one divided by this one? So let's do 1 divided by 2. So ar cubed divided by a times r equals 8 divided by 4. Well, what you should hopefully notice is that as you should notice here, these two a's can cancel each other out, and r cubed divided by r is r squared, and 8 divided by 4 is 2. So r is equal to the square root of 2. Now we know the common ratio is times in by root 2. So in our rule for the nth term, we now know the first value is what we need to find, but we know that the common ratio is root 2. Now the second thing we're asked to find is to find the first term. So remember, the second term is equal to 4. So to find the first term, we need to do 4 divided by root 2. So we need to do 4 divided by root 2 to get the first term. Now remember, from core 1 we can rationalise this third by timesing both the top and the bottom by root 2. So just as a side over here, let's just rationalise that third. So times the top and the bottom by root 2. So that's going to be 4 root 2 over 2, which is just going to become 2 root 2. Now we know the first term is equal to 2 root 2. So we're asked to find the 10th term in the sequence. So remember, the rule for finding the nth term is going to be a times r to the power of n minus 1. Well, we know we're trying to find the 10th, so that means we've got 2 root 2 times by root 2 to the power of 10 minus 1, which is 9. If we convert this root 2 to the power of a half on this second bit, just as a little side again, so root 2 we're going to make 2 to the power of a half, and then we're going to put that 2 to the power of half to the power of 9, which means it's 2 to the power of 9 over 2. So now I'm going to substitute this by what we've just found. So 2 root 2 multiplied by 2 to the power of 9 over 2, and if we convert our root 2 here to a half, and we're going to have 2 times 2 to the power of a half times n to the power of 2. Now you should remember that when you're multiplying powers, you add them. So a half and 9 over 2 is 10 over 2, which is the same as 5, and then you've got an extra one, so that's 2 to the power of 6. So finally, 2 to the power of 6 is equal to 64. So the final answer for the 10th term in this geometric sequence is 64. So the key thing here is to always write down what you're told in its form in terms of the term in the sequence.